Hey guys, today we're going to build a game called Connect4. Someone asked me to do it a while ago, and since I had day off on Christmas, I thought I'd do it. Speaking of which, Merry Christmas everyone. And today we're going to do just this game. So as you can see on the screen, we have two-dimensional grid. So you probably immediately started thinking about two-dimensional arrays. Then we have two players, so we could probably use a Boolean to switch between players. So red disk, yellow disk, to distinguish between players. So the goal of the game is to reach a combination of four disks of the same color, and that is pretty much it for the game. Right, so the first thing we're going to do, as always, create a package called Connect4. Create a Java class called Connect4 app, and it's going to extend the application. The pretty much the stuff that we do every time. Stage, set scene, new scene. Then we're going to create content for that scene in a method. Import this. Our entry point. We're going to use pane as a root node. Yeah, so we need to have a grid, and we're going to, this grid is basically a rectangle with a lot of holes in it, and those holes we can make using a circular shape. So we're going to create a shape, which is grid shape, make grid, and then we're going to add the shape to the root node. So next thing we need to do is to implement make grid, which returns a grid of the shape that we want. So we're going to start with a rectangular shape, and for that we also need to define a few constants. Static final int, tile size, say 80. In the rules it said by default it has columns, 7 columns and 6 rows, I believe. Static final int rows, and that should do it really. So new rectangle, column is, yeah, so it's columns plus 1 to make it slightly bigger than the actual grid, multiplied by tile size. That should give us the width, and for the height it's rows plus 1 multiplied by tile size. So this gives us a grid which is slightly bigger than the plain grid. And because it's a shape, we can subtract. So basically we can rip holes in that shape using circles. For, what is it? For rows, for X, which is columns, we'll create a circle, new circle with radius tile size divided by 2, because if you remember, radius is half of the diameter, and diameter is essentially the width of the circle. You also need to remember that in JavaFX, circle has a translate x of center x, so we want to be able to draw it from top left, or it's either it's easier to think about top left rather than center, because everything else is pretty much from top left in JavaFX. I wonder why this isn't. So we have to move it by the radius. So this gives us the top left coordinate when we use translate. I'm sure there was a perfectly good reason for that. So we're going to translate x by x multiplied tile size plus 5. This 5 will give us a bit of space between the circles. And we'll also move it by tile size divided by 4. This is the original position that we're going to move it by. So it's not going to be from left, it's going to be slightly, there's going to be a margin. The same thing for y. So we can pretty much copy and paste this because circle has the same width and height. Yeah, y value, that should work. Now, every time we create a circle, we then must subtract from the shape that we had, which is that shape, which is the rectangle, and this is accumulative. So this is going to be every time because we reassign the reference to the shape. And we're going to subtract circle from that. Return shape. So once we're done with this, the shape that is returned is going to be the shape of the grid. And we might as well set color. I think on the animation it was color blue, wasn't it? Yep. That should do it. If we run this. Oh, right, I haven't shown the stage. There we go. So this is the shape of our grid, and this is exactly the way we want it to be. Now, as you can see, it's kind of flat, as opposed to the one that we saw on Wiki. So what we're going to do is add some lighting to it. Light distant. Actually, I'm just gonna go to source and copy the example. Import that, and default values should be alright. Shape set effect lighting. So this will give us a bit of volume to the scene or to the shape, so it looks a bit nicer. Yeah, that's it really. As you can see, those circles, they're not actually objects because we don't add them as objects to the shape, we subtract from it. So there's only one shape, as it were. So, but we need to be able to add our disks along the columns. So what we need is some kind of overlay that will tell us which column we're targeting. And this overlay is going to be a list of rectangles. So if we have like vertical rectangles, I'm thinking make columns. List of rectangles, the list, array list, turn list. For, what is it, X columns. We are going to create a rectangle. Width is going to be tile size divided by 2, and the height is that. Yeah, that'll do. Rectangle, we need to set translate X because, well, Y is 0, which is fine. Translate X, and that X is, actually we can copy and paste this. So this will give us the X position of rectangle. By default, we would like the rectangle to be color transparent. Now when we hover with our mouse, so set on mouse entered. We'll replace the color to something like, I don't know, 200, 250, and opacity of 30%. And then when we leave the area, set on mouse exited. No, it's set on mouse exited. We set the fill back to what it was, which is transparent. And we need to make sure to add it to the list. Grid shape. Get children, add all, make columns. So this will be an overlay, or it should be an overlay. Although it's kind of small. Yeah, it's not supposed to be tile size divided by 2, it's supposed to be full tile size. Because tile size divided by 2 is per radius. Yeah, so as you can see, we can now kind of give a hint to the user which column they're selecting. Which means that on click, we need to provide some sort of place disk, which we are going to implement. First, we need a class for our disk, so class disk extends circle. Should only really have just one field, red. Make it final. So when we construct the disk, we pass in a Boolean value, which will say whether it's a red disk or a yellow disk. We also need to call the superconstructor with the radius tile size divided by 2 and the color, which is if red, then pass in color red, if not, yellow. Also need to make sure to set the center correctly, because it's a circle that we're extending from. So we inherit all its properties and behavior. Tile size divided by 2. Center Y, tile size divided by 2 as well. Place the disk. So in order to place the disk, we need to pass in the disk itself and column. The Boolean, which we need to have here as a flag that tracks whose move it is. So we'll start with the red user, red player, and then we'll switch it to yellow. So red move. So if it's false, then it's going to be false, and will come back as false. So it's going to be yellow because we only have 2 colors. If we had more, then you would probably use an enum new disk, and the column is we'll need to create a final variable, because this is not effectively final, it gets reassigned, and in lambdas we can only use effectively final or final. Final and what is it, column, and then we simply reassign x and then pass in column instead of x, because if we passed in x, compiler would have said no. Alright, let's place disk. So we need to have a grid which is two-dimensional grid of disks with columns width and rows height. Here we need to check if we can place the disk, so we need to have a method that returns disk given the coordinates. I'm going to use optional disk rather than disk itself because it can return null in case we don't have any disks on that position. And instead of returning null, we'll return optional, which is a better option. Right, so get disk and column and row. So column represents X and row Y, and I'm staying consistent with the order. So we're going to check for boundaries as always when we're dealing with arrays and stuff. Column less than 0 or column is greater or equal to columns, or row is less than 0 or row is greater or equals rows. We then return optional empty. So it is basically an object that we're returning and saying there is nothing that we can possibly return. So this is pre 1.8. Yeah, pre 1.8 you would return null at this point. And now we can return optional empty. This way we kind of guarantee that there isn't going to be a null pointer exception, and we kind of force the caller of that method to check for nulls or check for presence of the optional value. Okay, so get disk, return optional of nullable, because by default everything on the grid is null. Grid column row. So we select row from rows -1 because it goes from 0 to rows -1, and we add disks so that they fall down, so which means we need to start count from the maximum value and then to 0. Do a check while row is greater or equal to 0, and if row is less than 0, then return, because that means we failed to find a proper row which is empty. If not, get disk column row is present, then break, and then row subtract decrement. So yeah, we get the disk at column and row. We check if it's present. Optional is present will return true if it has a value inside, which means in our context that there is a disk present at that position. If not, then means it's empty. So we break out of the loop and continue to what we were doing, which is placing the disk. So we can now actually place the disk. Grid row is a column row disk. We added to the logical part of the game, but we haven't added to the visual part of the game. So we need to have pane, which is a root node for our tokens, for our disks. So I'm going to call it disk root. We are going to add disk root before the grid, so that it will have a nice overlay as if it is actually in 3D, although it obviously isn't. And we can now add stuff to the visual part, which is disk root, get children, add our disk. So we've placed it. There's also on the wiki page there was an animation when you place the disk, and obviously in real life when you play it, it goes down, falls down. And so we're going to add a translate transition, which is going to be our animation with duration of half a second. The thing that we're animating is the disk. Animation set to Y. Actually, I haven't set the X yet, so at this point we might as well do that. Translate X, and that X is that. Except there's no X, there's column. Set to Y is, it's the same, isn't it? Except this is row. Animation set unfinished. When the animation finishes, so when we actually add the stuff in, we need to check if the game has ended. Game ended. If yes, then show or do game over. And then at this point, we can switch the red move. So when the animation finishes, that means we've added the disk to the grid, and it's placed where it should be, and we can now switch the players. So if it was a red's move, it's going to be yellow's move, and vice versa. Animation play. Alright, now there are two more things that we need to implement, which are so it returns Boolean game ended and checks whether the game has ended or not. And then there is game over. For game over, I'm just gonna put this placeholder so you could implement whatever you want to do at this point. So I'm going to leave this up to you. I'm just gonna say winner plus if it's red move. If it was a red move, then we say winner is red, else we say the winner is yellow. As for game ended, this is where the actual algorithm comes in, which checks the disks and whether they create a combination of 4 or not. To simplify, we probably need to pass in column and the row of the disk that we've just added. So it's column and row. Right, row isn't effectively final, which means I have to define another variable, which is current row, which simply is reassigned from row, and then we can say current row. Game ended, we'll need a helper function, helper method, that will check a range, because there are essentially 4 directions in which a player can win. And those 4 directions are left, so from left to right, from top to bottom, and then the 2 diagonals. And the range length is 4 in each in this direction. So if we do a list of points, and each point is going to give us position, column, and row of a single item, single disk. Result is we start from 0, then for each point P in the list of points that we're given, so this is going to be a range of points, and we need to obtain column from that. The column is get X, the row is get Y. Then we can obtain disk at that position, get disk, column, row, but this returns an optional. So there may or may not be a disk at that position. So we call another function, another method called or else. So this will be called when there isn't a disk at that position. So we supply a new disk, which means that if there isn't a disk there, we cannot create a combination. So we might as well supply a disk which is a different kind of color, so that our check will fail and the combination chain will not continue. If disk red equals to red move, so if it was red's move, then we're checking if the disk is red. But because it's the same flag and because we only have two colors, when it's yellow, it's not going to be red's move, so this is going to be false. And if it's yellow, this is going to be false. So it kind of works both ways. So we don't need to define anything new. We then increment result by 1. If result hits 4, then we have found a combination of 4. If it is, however, a different color, then we need to set result to 0 back. Actually, I'm going to rename this to chain, because result doesn't really make much sense. And return false here. So if we've reached this statement, this position, that means we haven't found a chain of length 4, then we return false. And this is where we obtain the 4 directions, which are vertical, horizontal, diagonal, and like left diagonal and right diagonal, if you understand what I'm saying. Because there are 2 diagonals, from top left to bottom right, and from bottom left to top right. Right, the verticals and horizontals are easy, and we can define them just like that. Vertical. We take the int stream off. So if it can be done with streams, I usually prefer to do it with streams because I quite like streams. Kind of gives you a functional feeling. Range closed. Vertical is rows, so it's row minus 3, row plus 3. So column and row, these two are give us the coordinate of the position where we place the disk at the moment. Row minus 3 gives us the because we can create a chain of 4, we need to check up to 4 values in each direction. But we include the disk that we added, so it's not 4, but it's 3. Range closed, so we're actually including this as well. We need to now map to object, which is a point. So this will give us a stream of rows, which I'm going to call R. Then we're going to map this to a point which takes X. If you remember, X is column. So we're going to pass in column. Instead of row, we're going to pass R, because this is where the R gets incremented. So we're creating new points. And we simply collect this to a list. This is going to be horizontal, pretty much the same, except this is column and this is column. Row is the same, but the column is going to be different, which I'm going to call C. The rest is the same. Now for diagonals are quite complicated. They always are. Yeah, so the point that we're going to select is top left. And that point is obtained by column minus 3, row minus 3. So column minus 3 gives us the left point, row minus 3 gives us the top point, so it gives us top left. If you remember, we're still counting from top left, the origin, so the positive y-axis goes down. List of points, diagonal 1. So we take the int stream range closed from it's going to be 4 points either way containing the middle point, so it's 0, 1, 2, 3, 3, 4, 5, 6. We're going to map this to objects. So we take I, which is the value between 0 and 6 inclusive, so this is going to be increased every time in this stream. We are going to take top left and add I and I in X and Y. So this will go from top left diagonally, because we're adding to X and Y, all the way to bottom right. And I'm just going to copy and paste this for bottom left. Column, this gives us left. If we do plus, this gives us bottom point. Diagonal 2, range is the same, map to object. This is going to be bottom left. In X we add, but we go minus I, because we're going to top rather than to bottom. So we've obtained our range of points, vertical, horizontal, diagonals, and now it's as simple as checking the range. So the game has ended if check range returns true on either vertical or horizontal or any of the diagonals. And that should be it. It's been a while since I ran this actually, so we need to check it works. So if I select this, right, the animation seems to be working. So it's the reds, now it's yellow, now it's red, then yellow, red, yellow, and this should now print winner red. Yep, it does. And if I do it one more time, it should print yellow. Okay, so we've checked the horizontal ones. Now let's do diagonal. So that's yellow, red, yellow, red, yellow, red. Yep, so that diagonal seems to be working. Now it's for this one, so it's yellow, red, yellow, should print yellow, right? And the vertical, red, yellow, that should print yellow. Yep, that's fine. So we've checked all the possible combinations of the disks that create a chain of 4, and that is pretty much it. I've left this method for you to work with, so you can either create a dialog saying red or yellow has won, do you want to continue or do you want to exit, or something like that. And apart from that, it is pretty much a complete game of Connect4, or at least the basic logic of it. And thanks for watching, and again, Merry Christmas.